Hello, let's look at number 3. A uniform rigid bar of weight W is supported in a horizontal orientation as shown above by a rope that makes a 30-degree angle with the horizontal. The force is exerted on a bar at point O where it is pivoted, and it is best represented by a vector whose direction is in which of the following directions. So first, let's kind of draw a free body diagram showing the forces we do know. Okay, so we have this one. This is my Ft from the string, from the rope. And we also have mg. We know that mg is always from the center of mass. Okay, and we know that the center of mass is in the middle since this is a uniform rigid bar. Okay, and then we know that this Ft is going to be broken into two parts. Okay, so that green part here, that's going to have to counterbalance some with my mg. And then we have this blue part right here. Okay, now we need some additional force to counterbalance that blue, right? It's going into the wall, so we're going to need a force coming out of the wall, right? Pushing that way, okay? Now, because this isn't moving, I can actually put a pivot point anywhere I want, okay? Because it's not rotating about any point, right? It's not moving, therefore it's not rotating about any point. And so if I take a pivot point and put it here at the end, right, then this force here, this torque, right, this torque is going to be 0 because the radius is 0. And so I'll need some sort of torque to counterbalance that mg, right? That mg is going to cause it to try to rotate down, so I need some sort of force that's going to kind of rotate it in this upward direction, right? Mg is kind of causing it to rotate that way, okay? So I need some torque to make it rotate in that direction. So I also need an up right there, okay? So the wall must be exerting a force that is like this, okay? To the right, and then also a force that is up, so that would just be B.